Hey guys, it's Dr. Perrine, and I am using this both as a review tool as well as kind of some practice for how our course is going to look moving forward. This is a review of section 6B, and then in addition to that, it is covering the last little bit of content in 6B that we did not talk about in class, which is about box plots. And so we'll talk about standard deviation and range first, once again, like we did in class before the university closed. And then we'll talk a little bit about box plots. You have the handout that you're getting ready to see already, but I will also upload the box plot handout to D2L, and you'll have that up there as well. Okay, so anyhow, let's take a look through here. Take a reminder of how these work, and then the stuff that you see on the right hand side is off of your handout. It's one of the last pages in your handout in which you are given 10 data points, and you needed to find the standard deviation following the step-by-step process that we had, and we'll go through that together. Okay, so anyway, so we're talking here about Unit 6B, measures of variation. Remember that the range of a data set is the difference between its highest and lowest values. So if you come over here to our data set here on this page, right, what's your highest value? As you look through here, your highest value is 102. That's the highest value. The lowest value, 29, 22 is the lowest value, right? So if you wanted to find the range of the data set that's contained here in this problem, you just simply take the highest number minus the lowest number, and in this case you'll get a range of 80. Okay, and so that's a pretty simple way of looking at kind of variation. Unfortunately, it doesn't really necessarily tell us a whole lot. And so that's one of the things that is tough about this, right, is this is a really easy thing to calculate, but it doesn't tell us a whole lot. The standard deviation is a lot more complex, but it tells us a lot. And so that's where we're going to head next. Remember the standard deviation, we didn't give a formula for it, but basically I talked about it a little bit as it's kind of a averaging of the distance every point is from your mean in your data set. And we had a 6-step process, a 5-step process here for calculating the standard deviation. And so you have to find the mean of the standard deviation, then you find the deviation from the mean, which is subtracted. It can be a positive or a negative. You square those, you then add them all up, you divide by the total number minus 1. Remember, this is called a sample standard deviation. That's why we subtract the 1, and then we take the square root of it. And so you guys had, I think it was listed as a 6-step process on mine because I said counting the mean was the first step and then finding the deviation was the second. Your book combines them into one step, and so that's fine. And so I've got my calculator here, and so I'm kind of trying to do it in real time like you guys would be. And so I've already calculated the mean. If you want to find the mean, again, what you would do is you have to add up all 10 of these guys, add them all up, and divide by 10. And we came up to find that the mean, X bar, is 66. And so that calculation I assume you can handle. And so from here then what we do is we take each of these numbers, in this case 99, we subtract 66 from it, and that gives us a deviation of 33. If your deviation is positive, that means your data point was higher than the mean, and if it's negative, like up here, 22 is negative 44, then that tells you that your test score was lower than the mean. As we go through and we do all of these, 102 minus 66, right? 102 minus 66, and again, you've got a calculator, so if you want to make sure that you're doing it correctly, use your calculator so you don't do anything silly. That is 36 is your deviation, okay? There's nothing wrong with using your calculator for this. 33 minus 66 is a negative 33. All right, 57 minus 66 is a negative 9. Continuing, 75 minus 66 is a positive 9. 100 minus 66 is positive 34. 81 minus 66 is a positive 15. 62 minus 66 is a negative 4. And 29 minus 66 is a negative 37. All right. So again, one way to check yourself is to come down and add all these numbers up because they are signed. And so what that means is that you have, if the mean really is 66, it's the middle number of, it's not the middle number, it's the average, it's the center point sort of your data set, then it should be that when you add up all the numbers, the distance that all the numbers are above 66, and you subtract away all the numbers that are below 66, the distance they are from 66, then you should come up with 0. And so I'm plugging these numbers in, adding them up, and subtracting the negatives, obviously, and then I end those up and I get a total of 0. So in fact, if you add up these numbers, let's take that away. If we add up all these numbers, negative 44 plus 33 plus 36, all the way down to the bottom, you get a 0. And that's a good check on your values. Okay, but now if we want to fill this out, because we can't add up a bunch of things and get 0 and take any type of averaging because 0 divided by anything is 0, right? So now what we need to do is we need to square our deviations. And so 33 squared gives us 1,089. Okay, when you square 36, you get 1,296. When you square negative 33, remember when I put the negative sign in, if I plug it in my calculator with parentheses, that's negative 33 times negative 33, which gives you positive 1089, all right, 1089. So make sure when you plug it in your calculator, you use parentheses around your negative symbol and use the plus minus sign, not the subtraction symbol, or it'll be messed up. And so when you square these out, all these numbers should be 81. 81. All these numbers should be positive. Negative 9 squared is 81. 9 squared is 81. 34 squared is 1156. 15 squared is 225. Negative 4 squared is positive 16. And negative 37 squared is 1369. So if you now take all these numbers and you add them all up, you get 8,338. 8338. All right. So according to the step-by-step processes, all the squares, you divide the sum by the total of data points minus 1. There are 10 data values over here. We subtract 1 from that and get a 9. And so we take 8338, we divide that by 9 in our calculator. When you divide 8338 by 9, you end up with 926.4 repeating, so we'll just leave it at this. This is not our answer, this is our variation. Then what we have to do, our last step, is to take the square root of 629.4, and if you take the square root of that, you end up with 30.4. So 30.4 is our standard deviation for this problem, and that tells us when the mean is 66, the standard deviation of 30.4, that's a pretty big number compared to 66. That tells us our numbers are kind of spread out, and as you can see, obviously with these 10 numbers, they certainly are spread out. You have a lot of big deviations, 37, 34, 33, 36, 33, 44, negative 44 obviously, but without the signs you can see most of our deviations are quite large, above 30, and so it makes sense that our standard deviation would be somewhere up in that area. Okay, so that's the process for finding your standard deviation, and you need to know that process. You need to be able to do that on your own, although obviously we will have a slightly different testing format now, and so we'll talk more about that as we get closer to our next exam. Now on to the new stuff. All right, the new stuff talks about box plots and quartiles. Okay, so you can see here that what's known as the lower quartile is the first quarter, if you will, of your data set. You have to put your data set in lowest to highest, all right, and then you are basically breaking it up into 4 chunks, okay, where the middle quartile is your median and the lower quartile is the median of the bottom half and the upper quartile is the median of the top half. Okay, so let me show you an example here. Okay, we'll talk about how the box plots look in a minute. And so here's an example from your textbook. It is 2 banks and their wait times for 11 customers in each of the banks. And so these are in minutes, how long they have to wait. At Big Bank, the smallest chunk was 4.1 minutes, the longest was 11 minutes. And for Best Bank, the lowest was 6.6 minutes, but the longest was 7.8 minutes. So here you can see from the graphs that Big Bank kind of has a big spread of all their different wait times, and Best Bank has a very, very small spread. They have almost all of their data points in between 6 and 8. Well, they have all their data points in between about 6.5 and 8. And so while you're never going to get in super quick, you're never going to have to wait super long either. And so, you know, we at least the book comes up that Big Bank would have fewer happy customers or more unhappy customers because they might have to wait a really long time, and you don't really know. When you get to Best Bank, you kind of know it's going to take me 7 or 8 minutes to get to the teller, whereas at Big Bank you have no idea. You might get there in 4, you might get there in 11 based on this data. So what I want to do is I want to show you how to calculate these quartile things and then what a box plot looks like out of that. So if we come back over here, this is going to be in your new packet that you'll have to download as a PDF from D2L, and this is titled box plots. Okay, so what we're going to do in order to find your box plot, well, the first thing you have to do is you have to put things in order. So we get 11, and then there are 3 15s, and we have to list each one of them individually. So we get rid of all those now. Then we do 16, and then 17, 2 18s, and a 19. Okay, so now we're in order. So there are 10 objects here. Sorry, 1, 2, 3, 4, 5, 6, 9 objects, 9 values. And so we know then the middle number, that's the median, right? That's the middle number. Well, this is now also known as the second quartile. I'm just going to abbreviate it with a big Q. And the second quartile represents the middle number. The median, right? So this kind of divides your data in half. Half your data is below the second quartile. Half of your data is above the second quartile. If you think about it, 2 quarters is a half, right? So that's where we get this idea of quartile. Now, how do you find the first or the lower quartile and the third or the upper quartile? Well, the first quartile is the median of these 4 points. 16 was an actual value. 16 was an actual value in our data set. We now ignore it when it comes to looking at upper and lower quartiles. So now we take the rest of our data and we divide this data into 2 halves. This is the upper half. They're the highest numbers, right? And this is the lower half. And now we take the median of our lower half. Well, the median of the lower half, we've got 4 numbers, so we can't take the median. What do we have to do? We have to find, there's no middle number, right? So to find the median, we take the average of the middle 2 numbers, 15 and 15, they happen to be the same. And so 15 is our median, and that's known as our first quartile because it's the bottom. It breaks the bottom half into 2 halves, 2 smaller halves. Here's your first quarter, your second quarter, and now in your upper quartile, we have the same issue, median of the upper half, right? So we'll call this like the lower median, and we'll call this the upper median, okay? Also known as first, second, and third quartiles. And so we take 18 plus 18, just like we did before, divide by 2 and get 18. And so that is 18 is our third quartile. Okay. So now, how do we make this problem, or this how do we make this into a box plot? Okay, a visual representation. So I'm going to give myself a little bit more room down here. And then, so what I'm going to do is I'm going to basically draw a number line. Okay, at the end of this number line, I'm going to put my very first number, 11. And at the other end of the number line, I'm going to put my next number, 19. Okay, and there are 5 points of interest on each of your box plots. The smallest number and the largest number, that's your first 2 points of interest. Your third point of interest is the median. Try to place it about where it goes, 16 as a number line, right? And then 15 and 18 are your other points. So 15 goes here, 18 goes up here, and you could tick off 17 and 14 and 30, but you don't need to, all right? And so the way that we do this is that we spread it out like this. Here are your 5 points. And then we draw a box that goes from the lower quartile to the upper quartile and includes the second quartile here, the median. And that's a box plot. That's what a box plot looks like. And as you can see, what it kind of does is it kind of shows you, all right, on average, most of my numbers are a little bit to the right of center, right? The center number between 11 and 19 is 15. But the median was actually 16 for our data set because we had more numbers closer to 19 than closer to 11. All right. And the majority of our numbers, in fact, all but 2 numbers in this case, are between 15 and 18. So that's where the most of our numbers lie. Most of our numbers lie in between the first quartile and the third quartile. And so that's the way we kind of are looking at it. Okay? So if you come back to the big banks and the best bank example, all right, you'll notice what your box plots can do when you try to analyze data sets. All right, so for the big bank, it's on the bottom. And you'll see here's 4.1 all the way out to 11. You have this big spread of data. So the distance from 4.1 to 11, that's the range of the data, right? But then the distance between the first quartile and the third quartile, 5.6 to 8.5, is still pretty big. Look at how small the box plot is for best bank in comparison to big bank. This tells you that best bank has a much smaller range, a much smaller spread of the data. The variation is smaller, and therefore the mean for best bank, or in this case the median, would be a much better approximation for the quote average compared to this one. They both have a median of 7.2, right? They both have the same median. But here 7.2 doesn't mean hardly anything because you could be 4 minutes, you could be 11 minutes. Here 7.2 is pretty right smack dab as to what the average time would be if you had to wait. And so you can see the difference using the box plots. Okay, so your assignment is to make sure that you are comfortable with the standard deviation stuff, but now also to go in and play around with some of the box plots. There are 10 problems. I did one of them, problem number 2 here from your box plot assignment, but there are 10 total problems to work through on the box plot handout. And then obviously you'll have a box plot practice set in my math lab as well. Okay, so as always, if you have questions, feel free to shoot me an email or a text, and hopefully that gives you a good understanding of what we are covering and how we're going to do the rest of the semester. If you do have questions about or comments about the video, how it's turned out, how it sounds, how it looks, I need that feedback too. That will help me a lot in understanding what I can do and how things are working for you. Okay, so hopefully that went well, and we will see you soon. Bye.